Hi there. So let's solve this question. It says solve the equation here this where A is real and positive. Write your solutions in polar form in terms of A. Right? We don't have to find A. We have to write the solutions. So first, let's just copy the question. Z squared is equals to root 3 plus I over AI. Now, because I is in the denominator, I would like to rationalize it first. So when I rationalize, I just multiply and divide by I. So I am now with root 3I plus I square over AI square. That will give me root 3I minus 1 over A minus 1 is going to be minus I. Right? If I simplify this further, I'll move this minus sign up here, right? When I move this sign up here, I will have minus root 3I plus 1, right, over A. So I can write it as, just write real first, 1 over A is the real value, plus minus root 3 over AI is the imaginary value, right? So now Z square is equals to 1 over A minus root 3 over AI. Right, now they want the answer in a polar form. Polar means they need in the cos theta plus I sine theta form. So, and you have an R there as well. So first let's find R. So R is equals to square root of the real square plus imaginary square. So square root of real is 1 over A square plus minus root 3 over A square, right? So 1 over A squared plus minus square is plus, root 3 square is 3 over A square, and you have square root of that. So now if I simplify this, I will get 4 over A square and root of 4 is 2 and A, right? So that is our R value. We also need the argument. So argument is usually found as tan inverse of y over, or not y in this case, imaginary over real. So tan inverse of imaginary, which is minus root 3 over A over real, 1 over A. All right, so this is tan inverse minus root 3 over A divided by 1 over A. So when you solve that, that is tan inverse minus root 3 over A times A over 1. Cancel tan inverse of minus root 3. We know that tan root 3 is 60 degrees, all right, or pi over 3, but that is for the positive. So in your unit circle, if you've done that, here, this angle, this side here in the like in the fourth quadrant, tan is negative, right? So here this angle is minus pi over 3, right? So here the argument of this z square is equals to minus pi over 3. So now let's write it in polar form. So we will have R is 2 over A. Cos plus I sine theta is written in short form, it's written as cis, minus pi over 3, the argument, which is z square, right? Now we have to use de Moivre's theorems. So de Moivre's theorem, or you can write according to de Moivre's theorem, z square is equals to 2 over A cis. So when we are finding multiple solutions, we make it a general thing. So it's going to be pi over 3 plus 2 pi or 2k or 2 pi n or 2k pi. I prefer to write 2k pi, right, where k is any real number. Okay, we're still going. So now z is equals to square root of 2 over a cis, and here we multiply with half of that n, right? Or divide by n in this case. So that is going to be so that is going to be minus pi over 3 plus 2k pi. Z is equals to root 2 over a cis minus pi over 6 plus k pi, right? Now this is z. Now you can find as many solutions you need. We need 2 solutions because we have z squared. We need 2 solutions. So the first solution is when k is equals to 0, you will get z1 is equals to 2 over a cis. This becomes 0, so it's going to be minus pi over 6. Right? Z2, when k is equals to 1, is equals to root 2 over a cis. Now k is 1. So when k is 1, this is pi. So now you have minus pi over 6 plus pi. So if you solve that denominator, it's going to be minus pi plus 6 pi. So that is 5 pi over 6. 5 pi over 6. Cool. I hope this makes sense. Right. This is what they're asking. Have a good day.